Okay, so we have some data here, some energy drink survey data. And just for your reference, this is the chi-squared question, and it's on page 270 on the book. So if you're following this video, just make sure you're at 270 so it can help you follow along. Okay, so we have some data here, and we have, I guess, in a more modern data set, we would have other variables besides male and female, but we'll roll with this. We have male and female gender, and then we have preferences for 3 different brands of energy drink. And what we want to do with this data is we want to see if there's an association between the gender and the brand preference. We're not saying we don't want to have the conclusion, yes, males prefer brand 3 or females prefer brand 1. We just want to see if, there's some kind of cross impact, almost like a qualitative correlation between gender and brand preference. So the first thing is we're going to get it into a slightly better way of looking at the data. We're going to use that with the pivot table. So Control Shift down and across. And we're going to do an insert pivot table from table range. And we're going to actually stick it, actually we'll have it on a new worksheet, which we're going to call, will be our actual worksheet for this. Okay. So what we want is we're going to have the gender in the rows, respondent in the column. Whoops. We don't really want the respondent. We want the brand preference in the columns. And we're going to count the number. And one thing I think I mentioned, I've had questions on this. If you count, it doesn't really matter what variable you use, as long as there's no missing data. So we have here, we have the kind of the preference. We have what we call a contingency table, where we have brands across, and we have female and male, and then we have, for example, in the rows we have the total females and the total males. In the columns we have the total preference for brand 1, brand 2, and brand 3. Now what I'm going to do is I'm going to kind of copy this, and I'm going to paste it below. So home, paste. And I'm just going to paste values so it doesn't take any junk from the table. Let's just kind of format it as in the book, where the headers, we're going to make it a kind of a lightish greeny yellow maybe. And we'll put the total values to be, what color should we make those? We'll make those like a light blue. And we'll make the grand total orange. Okay, so there we go. Now, what we have here is we want to have this as a table of expected frequency, and this is basically the frequency if they were independent. So what we're going to do is we're going to just basically each of these is going to be the row total times the column total divided by the grand total of observations. This is really just follows on from independence of probabilities, in that if male and female gender and brand were independent, then given 100 items, given 100 runs, we would get these values if independent. So let's remove these and put them in by our total. So we basically want, and this formula is on page 270, we want the row total times by the column total divided by the total. Okay, so now basically we don't want this to move, the E13. The B13, we don't want it to, where are we? The E11, we want it to move down, but we don't want it to move across, so we'll put $1 on the E. And the B13, we want it to move across, but we don't want it to move down, so we'll put $1 on the 13. Recall the dollar, just when you drag it, it doesn't change the cell reference. So we've got 12.58 there. Select that, Control D, and go to the right and Control R. And do I agree with the book? Yes, I do. And you see, for example, this one is the row total times the column total all over the grand total. So by using the dollars, we only actually have to put it in once. Now, the chi-squared is basically the difference between, it's basically the observed, and again, this is 270, observed value, what we get. So it's kind of how far we are away from our expected frequencies. And you don't think we have enough tables? Well, let's have another one to build up the chi-squared. And basically, each of these is going to be the kind of the constituent of the chi-squared, and this is equation 7.8 on 270. And it's just literally going to be the observed it's going to be equals observed. Okay, let's just B5. So observed minus expected squared. So it just squared in Excel is the power of 2 divided by the expected value. So we're just seeing how far we are away from the expected value. And we can actually just drag this right, and we can drag this down. No, we're going to drag it all the way down. Okay, so these 6 values are the observed minus the expected squared divided by the expected for each of the cells. And so we're going to have our chi-squared calc is going to be just the sum of all these values. And what we do is we have a chi-squared distribution. So we can actually have a chi-squared significant from which we reject. And the idea is if this chi-squared is bigger than a certain number, we have enough evidence that there's a difference between our distribution and the expected distribution, and they're dependent or associated. And actually, let's just add some other things. Let's just add our alpha or significance level, our type 1 error. And this is going to be 0.05. And then the degrees of freedom this is going to be basically the number of rows minus 1. So this is going to be 2 minus 1 times the number of columns minus 1. So times 3 minus 1. And again, that's given on page 271. And the chi-squared, we always use the chi-squared this dot right-tailed. We're looking at the right tail of the distribution. Sorry, we're using the inverse function as we're going from a probability to an actual chi-squared value. And we put our probability at alpha, and our degrees of freedom. And there we get 5.999. And our rejection rule is basically we're going to reject. So we just put if my chi-squared is greater than my critical value, then yes, reject. Otherwise, no, fail to reject. So here, our chi-squared is greater than our chi-squared significant. So we actually, yes, we reject the null hypothesis. Now, let's just kind of give you a little bit more on the hypothesis. So let's just do a full screen snip. Okay. So we have, okay. So my null hypothesis, oh, we were in red, but let's just kick with red, is that, and this is given on page 269, the two categories are independent, so gender and brand preference are independent. And H1, gender and brand preference are dependent. And my kind of what I'm going to do is I'm going to calculate my chi-squared. So my test statistic is going to be, we're going to reject. So reject if the chi-squared is greater than my critical chi-squared. And it looks a little bit like this, the chi-squared distribution. That's a terrible attempt. I'm not. It's like a little, yeah, it's a little bit like that. So imagine that we're going to be. This is my chi-squared. Critical. We're going to reject if my chi-squared is anywhere in here, and in fact, my chi-squared was approximately going to be here. Now, the last thing we could probably do is again we can reject on the p-value. So I'm going to just put a p-value here. And now we do use the chi-squared dist function. So we're going, and again, we use the right tail because in my diagram I just showed you we're looking at the right of the chi-squared distribution. This time we use the dist, and we use our calculated chi-squared and our degrees of freedom. So we always use the dist if we're going from a kind of a statistic value to a probability, and we use the inv if we're going from the probability to the statistic. And you see that my p-value is 0.03, which is less than 0.05. So again, it's the same. It's exactly the same. So we reject.